All right, ladies and gentlemen, it's Mr. Marchetti back once again in his basement with longer hair, looking more and more like an anime character. Don't know why I'm talking like this. Don't know why I'm calling myself Mr. Marchetti. We're all breaking a little bit. Alright. Well, last time I saw you in video format, I didn't see you. What am I talking about? Clearly losing it. But last time I made a video, we talked about engineering solutions to problems. And it's a little more detailed than just regular problem solving. Again, there's nothing wrong with regular problem solving, but when we talk about engineering a solution, it's a little more of a detailed process. Kind of like just casually observing something versus using the scientific method to observe and test and study something. That's kind of the difference we're talking about here. So, step one of the engineering process is to identify the problem and constraints. Talked about that last time. Step two is doing research. Why do you need a research? Well, pretty easy. One, it's to get a better understanding of your problem. And two, it's to see what's already been done out there to solve your problem. A lot of times, someone already came up with a solution. Sometimes, that's not always the case, and it's good to have a better understanding of what you're dealing with and what people have done already to address it. So we're going to start out with more casual methods of research and then go to more detailed ones. Take what you want from this. I'm just going to say a whole bunch of more times, but go ahead, guys. Take what you want, have your own beliefs, so on and so forth. This is just what I suggest in my own personal observations. Here we go. So what I use most myself personally, but is also can be very misleading, is Google. I use the Googs. I Google it for a lot of the problems I'm dealing with. It's quick, it's easy. I do YouTube too. In all honesty, for the same things. If I want to see a video demonstration, it's quick, it's easy, it's just really you type in what you're looking for, and usually a website or video comes up, whether you're using Google or YouTube respectively. The downside with using Google and YouTube, for both of those, is you may not realize it. I mean, I'm aware of it, but I still do it sometimes, is I watch the most viewed video. Or I read the most viewed article, and that's how Google and YouTube work, is if it's the most viewed or most popular, it's the thing that gets viewed and watched more. It's not always the best, though, which is the problem, and that's why it's important to expand your horizons and try other forms of research along with that to get information. Fun fact about Google and YouTube is you can buy viewers, you can buy number of clicks on a site and things like that. It happens all the time. So just keep that in mind. And things are sponsored, things are biased. It's a mess. So Google, YouTube, just if you are using those, you might want to do a little more digging beyond that. On that note, Google and YouTube represent two different forms of research. Google is more print because you're reading from articles, and YouTube is video demonstration. Now, when we talk about engineering and problem solving, sometimes you need both. The benefit of print is you can reference it pretty quickly, believe it or not I say this. Like if you watch a video, you might have to watch the entire video to get a small chunk of information and you don't necessarily know where that is. Unless you time stamp whatever it is, the part you're looking for, but usually videos don't have that. And where in a book you can look at the table of contents and be there in seconds. That truly is a benefit to print. The other thing about print that is really nice is if you're more visual or if it's something you're trying to memorize fully, print is actually real nice to quickly reference, look at, read over a bunch of times till you get the understanding. Where videos, it's really hard to do that, believe it or not. I know it sounds weird, but that's true. On the flip side of it, watching a video can be so much more beneficial than reading print, especially when you're describing an action or talking about a skill. Think about learning how to properly cut with a knife. You can read a detailed description of that 400 times, and a 20-second video is more effective than that. So just depending on what reason you're using it for and what type of learner you are, you may want to choose a print or video version of that. So here we go. When we talk about print, though, what are ones of value? Well, newspaper articles, things like that, magazines. I'm actually going to pull up some magazines right here. This is actually one of my wife's. It's Counseling Today, which is a magazine all about counseling. But when you have a magazine, remember, it's usually someone else reporting on their understanding of what someone else did. So even this book, which is all written by professional counselors, and journalists and things like that, they're often reading someone else's scientific study and then reporting on it. So you're kind of getting that information secondhand, which leads me to scientific journals. Scientific journals are great, but they're really content heavy, like really content heavy. This is one of my wife's too. This is the Journal of Child and Adolescent Counseling, and this particular issue has about 5 or 6 scientific studies inside of them, and the lab studies, lab reports, and things like that. Very, very specific in terms of content, and it's just about those 5 studies. Dry, cut and paste. You, as the reader, interpret, read the data and everything and make your own decisions based on that. Where a magazine, you're getting another author's perspective, if that makes sense. So scientific journals and journal articles are really, really, really helpful if you want to get the source of the information a lot of the times. Which then leads me to meta-analysis and books. So real quick note, in journals like this, you oftentimes have what's called a meta-analysis, where you take a whole bunch of scientific studies on the same topic and see what all of them come together and see what they mean. Side note, you'll probably learn about that more in high school. But then we have textbooks. Now there's really 2 different types of textbooks. So like this is one of mine right here. It's Best Practice in Teaching. This is more of like a meta-analysis that I was just talking about, where they take all successful studies and kind of come together with their own philosophy. So textbooks sometimes can be really presenting you a how-to philosophy type things, and when problem solving, whatever your problem is, a big thick book like this can give you a lot of detailed information about specific things. But then you have the opposite, which is, this is an engineering one I have. This is pretty much everything you can think about in mechanical engineering and design, summarized in 3 to 4 pages. So what that means is there's probably, like, in all honesty, I'd say hundreds of topics covered in this book right here in 2 to 3 pages apiece. Nothing in that great a detail like you would find in here, but you could probably find everything in here. So you might want to reference all these things when problem solving. Things we don't talk about a lot when you talk about research, or we don't really go into a lot of detail about it, or don't think about it, is face-to-face, asking someone. You can ask a professional in that area, and sometimes they'll answer, which is true. Downside to this is they're hard to find, especially in times like this. I mean, you might get more luck calling someone or Zooming someone now than you ever did before, but oftentimes it's really hard to, like, say you have a question about, I don't know, problem solving with, I don't know, pistons or something like that, and knowing people who are familiar with how pistons work is few and far between, and you might want to give someone a call and they might be busy. It's just harder to do. It's not always possible, but when it is, it can be extremely helpful. Mentorships and apprenticeships, great forms of learning and doing research and talking to people. I highly, highly, highly recommend that if you ever can, if you ever have a problem. The one thing that is often forgotten, and it's what I'm going to be doing in my jump roping situation, is called reverse engineering. And reverse engineering, believe it or not, is a form of research. And what you do is you take a look at something that's already been done and work backwards and figure out how they got there. That's why when you have tech shows, and you might have heard this last year in the news, why the company Huawei was not allowed in tech shows anymore, is because they take pictures of people's final products and figure out how they did it and work backwards. So, doing that with my jump rope right here. This is a broken one my wife has. Looking at this, this is the handle or grip, and I'm noticing it doesn't pull out the rope. The rope is made of like a material that obviously broke, but inside this hand grip here, they have a little ball that fits inside the handle.
and I'm wondering why they do that. I noticed it can't come out when they do that, and that's something that's definitely true. So I'm noticing this design right here. Reverse engineering it, what they did was they got the cord, and then they put some sort of like stopper here, and then put a handlebar on for tight grip. Looking at another jump rope that my wife has, they took a different approach. I'm noticing they still have a handlebar, but instead of putting the like a ball at the end and having it fit, like instead of this design right here, for this one, this model jump rope has a tie-off at the top right here, and it looks like they got the cord and in the handle itself made a like a loop or two holes right that so you could loop it, and then they put the stopper here so you can adjust the size of the jump rope as needed, whereas this one they just use the handle as the stopper. I don't know how that's going to behoove me later. I'm going to do some more research when I start to brainstorm ideas for the jump rope I use. I think it will depend on what type of material I use, which is also something I'm researching when it comes to this, is that this jump rope is made of a form of PVC plastic. Cool. When I looked at the box, neat. It's a weak form of PVC, I thought. And this one is made of woven metal in a plastic casing. So both of these ripped, and I'm trying to figure out, I needed something either thicker or stronger. I noticed both of these designs are the same width, and I'm wondering if that's important, and why I can't play with a thicker rope, because that might help me or behoove me. And both of these are weighted, and both of these weigh the same thing. The way this one worked is you take the weight there and put it inside the jump rope handle. Like you put this in here, and you put the weight inside, and then there's a cap that flew off. So, I don't know. I'm going to do more research and look at how these are made, and then brainstorm my own solution, and that will be in the next video. Alright guys, take care. If you have any questions about research and why things matter and why you need to research, or different forms of research, I'm going to see how many times I can say research at the end of this video. But anyway, take care. You know I miss y'all, and see you later. Bye.